Welcome to an exploration of human-machine teaming, a groundbreaking field that amplifies human intelligence with advanced machines to achieve new heights of efficiency, decision-making, and operational excellence. Human-machine teaming, or HMT for short, is a powerful force reshaping our defense where decisions that carry immense implications for global security and the safety of American forces often must be made in seconds. So, what exactly is human-machine teaming? In essence, HMT is about collaboration between humans and machines, where each brings their unique strengths to the table. While machines excel at processing vast amounts of data quickly, humans are irreplaceable for their ethical judgment, creativity, and ability to operate in uncertain environments. Together, humans and machines create teams that are smarter and faster than either could be alone.
In my simple mind, it's about, in an increasingly complex world, marrying the strengths of humans with the strengths of machines. Humans have strengths and weaknesses, machines have strengths and weaknesses, and I think the marriage of the strengths and weaknesses of the two allow us to do that at a level that we need to, particularly in military operations, which are, very complex by nature.
The real tenets of human-machine teaming involve a lot of flexibility. The idea that humans and machines can work together jointly on really complex tasks. And the whole notion of the benefits of human-machine teaming are that you could get a machine to start to work proactively with a person, right? So a human might be able to leverage a machine to do some breadth of information analysis or acquisition, to allow the machines to filter information for us, or to build courses of action analyses, sorts of capabilities in a very rapid way, because machines are great at the compute, humans are great at decision making, and so when you pair the two together, greatness is a potential there.
So the way I think about human-machine teaming technology is really, the machine is a tool, and the question is, what do we want it to do with what information we want it to do it with? The goal of the tool is really to help us have a relationship with knowledge at speed and scale.
In practical terms, this means developing systems that augment human decision-making by providing machines the autonomy to perform repetitive or computationally intensive tasks, freeing up human operators to focus on strategy, ethics, and creative problem-solving. The Air Force Research Laboratory plays a central role in advancing human-machine teaming technologies. As the world becomes increasingly complicated, with threats that are volatile, uncertain, complex, and ambiguous, or what's often referred to as VUCA, the need for HMT is more critical than ever. AFRL aims to create systems that allow military personnel to make faster, more informed decisions.
We've always at AFRL had a history of teaming with machines, whether those are the planes we put in the air, the unmanned vehicles, or whether that are the computers or other types of sensor technology. The reality is we always need to have an advantage when it comes to our relationship with information and knowledge.
So at AFRL, we define autonomy as giving some computer agent a delegated and bounded authority to take actions in space. So a lot of our work is, how do we make sure that humans can properly communicate what the delegated authority is that's given to that agent? And how do we build systems that are watchdogs that can monitor what this AI is going to do to make sure that the bounds that the humans give it are always held?
We, of course, because we're an applied research lab, we develop technologies that support directly human-machine teaming applications across the DAF. And so that involves working with programs like Collaborative Combat Aircraft, with ISR systems, intelligence systems, could be maintenance-related systems. So we build actual technologies that support these programs and support these needs across the DAF and of course across the Space Force as well.
So AFRL is investing in human-machine teaming because we think this is an area that has the potential to deliver transformative technologies for future warfighting missions in all domains. We hope that these technologies will expand the scope and capabilities of military operations by accelerating the decision cycle of the human operator, while at the same time reducing the risk on the human by allowing them to remove themselves from the highest risk aspect of the mission.
Human-machine teaming will revolutionize military operations. Imagine a future battlefield where unmanned aircraft collaborate seamlessly with human pilots, or where autonomous systems help analyze enormous data streams to provide commanders with actionable intelligence in real time.
We live in an increasingly technology-rich world. I think if you look at the speculation of where military operations will go into the future and understanding that we need to maybe shift our thinking from few exquisite, very costly things to smaller, cheaper things, the battlefield is going to be littered with more and more machines, and therefore the ability of humans to interface with those machines in a synergistic and coherent way is going to become increasingly important.
Machines are great at compute. Machines can process things that humans can't fathom in terms of speed and breadth of information analysis that they can do. So why not try to leverage that as humans? We're great at decision making, we're great at pattern recognition, we're great at creativity. So the thing is, how can we get machines to play into that whole process? So understanding what the humans do and use the machines as a means to accelerate what they're doing already.
Human-machine teaming is important because without it, we will lose. Without using the augmentation, the relationship with knowledge and with the machines that we have at speed and scale, we will no longer maintain the dominance in the future battlescape or battlefield. So it is not an if we do human-machine teaming or we use artificial intelligence. It is a must, and we must use it better, faster, with more curiosity, more optionality, and more advantage than the adversary.
It's incumbent upon us to be able to understand these new technologies, especially AI that is coming out, and be able to adopt and integrate them with our warfighting systems to make them better. And the reason for that is that our adversaries are also working on it. And our adversaries are developing technologies just as fast as we could. So for every bomb that we make, they have an equivalent bomb. For every missile, every airplane, they have. So our adversaries are achieving technological parity. So what will be the differentiator in a future war? I think the differentiator will be the ability for us, for the war fighters, who can better integrate with the machines and develop this truly unique symbiotic human-machine teaming system that will be better than any weapon or any single warfighter, and that can give us a decisive advantage over our adversaries. So that is why it is so important to invest and adapt and adopt these technologies now.
But human-machine teaming isn't without its challenges. One of the most crucial factors for success of HMT is trust. How can we ensure that operators trust the machines and can confidently use this capability? Just like you need to have trust in your wingman or partner, we need to build the same level of trust with machines if we want them to help us win.
One of our really big challenges in human AI teaming is making sure that we appropriately calibrate trust to the capabilities of the autonomy. So we don't want a human operator to overtrust AI and use it in situations that it wasn't designed for, but we also don't want it to undertrust and not use it when it would be better suited to deal with that technology. We're really looking for this trust calibration where they appropriately trust it in the situations it was designed for. So first, let's think about how do we even define trust? So when we're thinking about trust of a human and autonomous or human AI team, we're thinking about the human's willingness to accept vulnerability in situations that are characterized by uncertainty because they believe that that autonomy is going to help them achieve the mission that they need.
Yeah, I mean, I think there's this concern that at some point things are going to go what I would call sentient. I think that's the concern. I think that's a misplaced conception based on my understanding of technology. I certainly understand the fear, but I mean, we are going to have the right risk posture for anything we develop based on uncertainty, developed by test and engineering. I mean, it's going to be underpinned.
We've really tried to push the idea of responsible use of AI. So across society, you've probably seen concerns about artificial intelligence and things like bias. In our view within the Air Force, we're trying to push the idea that machines don't really have ethics. When they can understand context we might have a different conversation. But at this point in where the state of the art is, they can't really understand context all that well. And so in our view, it's hard for them to ingest ethics, right? So the best we can do is try to push for responsible use of AI.
But building that trust factor into the operators, and I think this is where the lab can help, demystify things, I think is going to be very, very important. But if our folks don't trust it to utilize it in an effective manner on a timescale of relevance, it really doesn't matter.
Human-centered design is another critical element in the development of HMT technologies. For these systems to be successful, they must be built with the human user in mind from the very beginning.
Yeah, so how important is the human in the human-machine teaming equation? Of course, it's critical. And this is a point that if you work in isolation outside of a multidisciplinary space, it's probably easy to forget the human if you're someone building hardware or building software. You're just trying to put out the best solution that meets a particular need, right? But the human is critical because at any point, at least at some point, the human's going to have to use that technology.
So I think there's often misconceptions about human-machine teaming. I think the first one is that the machine somehow matters more. It doesn't, right? Again, the machine just does what we tell it to do with what we tell it to do it with. So I think the most important thing that people should think about when we think about human-machine teaming is, how do we want to show up? What is the humanity we're bringing to it? And more importantly, are we coming in with that learning mentality, that consistent learning, opportunity, and are we adapting as we learn? I think that's going to be the most interesting and most important part of human-machine teaming in the future, is really, how do we show up?
In addition, we're taking a lot of lessons learned from the Automatic Collision Avoidance Technologies program, which had 3 high-level requirements. The first was to do no harm, second was to do not interfere, and the third was to prevent collisions. So our big lesson learned from that is that there's a lot more complexity to developing these human AI teams than just getting the mission done. We need to ensure that, in this case for Auto GCAS, Auto ACAS, it was preventing collisions, but we need to make sure that in introducing that, we're not doing damage to the larger system, and that we also are making sure that we're not interfering with the human when they're trying to do something.
I actually think in human-machine teaming, the human is the most important, but more importantly, it's also the most unpredictable. So if you think about it, if I am going to do a query or use a particular technology or design a relationship with the machine, I'm still inherently influencing it from my experience and expertise. I like to joke that my husband wishes I had a predictable operating system, right? That he could put the same thing in and get the same thing out. And so oftentimes people will talk about AI, and especially generative AI as an example, and say, well, how do we get the exact same and repetitive and concrete answer? And the reality is sometimes you won't, because the knowledge base is changing, but more than that, you as a human change every day. If I have an experience, for example, or we're seeing an experience unfold in a battlefield, far away, we are learning every day. Our strategy changes every day. Our information flow changes every day. And so in fact, that learning mentality, that curiosity, that desire to adapt, to curate at speed is really important.
I think for the foreseeable future, I don't really imagine a time in which humans are going to be taken out of the process, especially in the Department of Defense. Humans and AI are always going to be teaming together in some way, shape, or form. They're completely critical to the decision-making and enforcing our norms and our belief systems as a country into the technologies.
I would repeat what Jonah Goldfein once mentioned in one of his speeches, that the future wars will not be a war of attrition, but war of cognition. It's true, right? Our adversaries are achieving almost a technological parity with us. So it will be the capability of our war fighters who will many times have to overcome the negative effect of stress, of fatigue, of lack of sleep, and still be asked to perform at their optimum level in the fog of war. And so that's why investing in technologies that really integrate the human with the machine to extend their capabilities as well as improve the efficacy of the machine in turn is why the human element, keeping the human in the loop, is so important and cannot be ignored, because it's not the machines but human that fight wars.
At the heart of human-machine teaming is the concept of decision superiority, being able to make the right decision faster than an adversary. In a future where decisions need to be made in milliseconds, the combination of human insight and machine speed will be key.
So the OODA loop was created by Colonel John Boyd, and in essence it was a framework that is familiar to a lot of people in Air Force, Space Force, and really in DoD generally. And it stands for observe, orient, decide, and act. So if you think about it, that's a very normal process that we go through to be able to understand what do we do next.
Decision superiority is about getting ahead of our adversaries' OODA loops. So getting faster decision making, so accelerating our Guardian, our airmen decision-making processes without sacrificing accuracy. So we talk about the speed of relevance. The speed of relevance is going to depend on what that particular mission set is. It could be seconds, it could be hours. We view human-machine teaming as one of the key enablers for decision superiority, because we recognize that machines bring to the table computational power that we just can't get as humans.
And so we really have to start thinking about time like a weapons platform, right? And oftentimes when we think about human-machine teaming or AI, what we're really doing is wormholing the OODA loop, right? We're saying, how can I have all of those options, and how can I go, from maybe orientation to being able to make a decision faster?
Looking ahead, the future of human-machine teaming is bright. We're moving towards systems that can learn and adapt alongside humans to create teams that can operate in highly complex environments with minimal supervision.
Today we are 1-to-1, simplistically. 1 human to 1 jet, 1 human to 1 spacecraft. In the future, it's going to be 1-to-10, 1-to-100, 1-to-1,000. And human-machine teaming underpins us being able to effectively operate at speed, to be able to make decisions on a timescale of relevance. Absolutely, it underpins all of it.
So one of the things that I often think about when it comes to optionality is, how does optionality exist in our world now? So if you think about it, if we were playing tic-tac-toe, you and I are both considering about 9 moves that we can make. If we were playing chess, I think it's about 36. If we were playing AlphaGo, we'd have about 360 different moves that we could make. So if you think about it, the more moves, the more complex, the harder. But again, we're playing a game. So in some cases, that game really matters about playing it at speed. So when I look at a situation where we may have an adversarial context, the question for me is, well, do I want to be able to process 9 potential outcomes or moves? Or do I want to be able to process 360? Quite frankly, I want to be able to process 3,000, right? Because by being able to look at all 3,000, what I'm really doing is in essence saying, where is my advantage? And if I can do that rapidly, faster than my adversary, it also means that I can move faster. I can maintain first mover dominance, and that's critical. And that optionality also hits home for me in the idea of human-machine teaming in a very powerful way. And that is, the best options also mean potentially the lowest loss of life.
The future is all about greater synchrony, greater longitudinal learning over time. So at what point do we get tools that can start to learn our preferences, that we can maybe set some of those thresholds for the learning processes themselves and get them better tuned to us and more in sync with us as individuals, right? Do more work in terms of getting those interfaces right so that we can set those bounded delegated authorities in a flexible fashion so that the machines are working for us and not against us.
The future of human-machine teaming is one where the role of machine is complementary and not redundant to those of the human. So in an ideal human-machine team technology, it would combine the strength of the human, such as reasoning, perception, contextual adaptation, with the strength of the machine, which is fast processing, unbiased decision making, while at the same time overcoming the weaknesses of the human, such as fatigue or bias. And so in the future, I see the human-machine team as the man and the machine come in a truly symbiotic fashion, where the man, a human, learn to trust the machine, its intelligence, and decision-making capabilities, and the machine in turn learn how to understand and respond to the human state, whether it's physical or cognitive, and understand the context and adapt to it, but perhaps more importantly, understand our values.
Human-machine teaming is not just a technological innovation, it's a revolution in how we think about human potential and machine capability. As we push forward into this exciting frontier, the collaboration between humans and machines will unlock new possibilities in every sector, from defense to healthcare to everyday life. Stay tuned, because the future is coming fast, and it's powered by human-machine teaming.